What is Millman's theorem and what does it state? Millman's theorem, named after Jacob Millman, is a theorem used to simplify the solution of a circuit, specifically, calculate the voltage of the ends of a circuit made up of only branches in parallel. The theorem states that when a number of voltage sources, for example, V1, V2, V3, and so on and so forth, are in parallel having internal resistance R1, R2, R3, so on and so forth, respectively, the arrangement can be replaced by a single equivalent voltage source V in series with an equivalent series resistance R. In other words, it determines the voltage across the parallel branches of the circuit, which have more than one voltage sources. It reduces the complexity of the electrical circuit.
This is another tutorial video in electronics brought to you by Lance. Okay, I have a problem for you. Find the current across the 7 ohm resistor using Millman's theorem. Got this circuit. We can see 5 voltage sources and 6 resistors. But first, let's discuss Millman's theorem. Okay. Millman's theorem states that when multiple voltage sources are in parallel, having internal resistances, respectively, the arrangement can be replaced by a single equivalent voltage source V in series with an equivalent series resistance. We can summarize that statement with this equation. V equals V sub 1 over R sub 1 plus V sub 2 over R sub 2 plus V sub 3 over R sub 3 plus dot 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 plus V sub n over R sub n, all over 1 over R sub 1 plus 1 over R sub 2 plus 1 over R sub 3 plus dot 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 plus 1 over R sub n. Let's make it clearer by looking at these circuits. In this circuit, we can see multiple voltage sources connected in parallel. According to Millman's theorem, we can simplify this whole circuit into a simpler one with an equivalent voltage and an equivalent resistance. Okay? Now let's get back to our problem. So we can see in this branch we have 2 voltage sources. In this branch it is okay because we only have 1 voltage source and 1 resistance. In this branch we have 2 resistors. In this 4th branch is okay because we already have 1 voltage source and 1 resistor. But in these branches we have multiple voltage sources and multiple resistors. So we can still simplify this circuit into a simpler one. We will add up these 2 voltage sources. 4 plus 2 equals 6. And then just copy this resistor with its value, which is 12. For the second branch, let's just copy. For the third branch, since the 2 resistors are connected in series, we should add them up. 4 plus 3 equals 7. And then just copy the voltage source. For the fourth branch, just copy the values. And of course, for the fifth branch, we have our 7 ohm resistor. Now, we can solve for the current through the 7 ohm resistor. Okay? Using Millman's theorem, it's 12 plus V sub 2, which is 10 over R sub 2, 5 plus V sub 3, 21 over R sub 3, 7 plus V sub 4, 9 over R sub 4, 4, all over 1 over R sub 1 plus 1 over R sub 2 plus 1 over R sub 3 plus 1 over R sub 4. And then we will get 11.4612671. Let's round off to the two decimal places. Now we got the equivalent voltage. Next, we should compute for equivalent resistance. Using Ohm's law, or using the properties of circuits, we have the equation 1 over Req equals 1 over R sub 1 plus 1 over R sub 2 plus 1 over R sub 3 plus dot 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 plus 1 over R sub n. Applying this equation, this formula, 1 over Req equals 1 over 12 plus 1 over 5 plus 1 over 7 plus 1 over 4. R sub 1, R sub 2, R sub 3, R sub 4. One over Req is equal to 0.676761904762. So Req will be 1.478873.239. Let's round off to the two decimal places. 0.48 ohms. Now we already got the equivalent voltage, the equivalent resistance. We can now get the simplest circuit for this one, which is the Millman circuit. Using Millman's theorem, let's get the equivalent voltage, 11.46. Then equivalent resistance, and of course our 7 ohm resistor. We are asked for the current through the 7 ohm resistor. Okay, using Ohm's law, V equals I times R, we can find the current I equals V over R. So you will get the voltage, which is 11.46 volts, over, let's add these two resistors because they are connected in series. 1.48 plus 7 equals 8.48. 11.46 divided by 8.48 equals 1.35 amperes. Now, that is the current that is passing through the 7 ohm resistor. .35 amperes. The summary of steps. First, we will simplify the circuit. Okay. Step, solve for the equivalent voltage using Millman's theorem. Then solve for the equivalent resistance, also using Millman's theorem. Then put them in a equivalent circuit. The values, this one, with the 7 ohm resistor, because we're looking for the 7 ohm resistor. Then you can add this up because they are connected in series. 11.46 divided by 8.48 equals 1.35 amperes. And that is the current is passing through the 7 ohm resistor. Thanks for watching. Goodbye.